Right, let's see. Chemistry, homework. Probably a sheet or something. Prepare a summary of pages 34 to 35 to include the list 1 to 3 below. Hello there! Been a while since you've seen me, huh? Well, I'm now here to teach you about health related to triglycerides. So, without further ado, and because the more I talk, the harder it is to animate, let's begin. Since we've already done fats, yet it was a while ago, here's a quick recap. 1. Alkenes have a special type of easy isomerism, which is known as cis-trans isomerism, where each carbon of the CC double bond has an atom or group that's the same. 2. The two types of isomeric forms are cis and trans. Cis has the atoms, in this case the hydrogens, on the same level, where trans hydrogens are on opposite levels. A helpful way to remember this is trans. If a food is high in saturated fats, as in doesn't have double bonds, then it's bad, as it can increase heart disease by raising blood cholesterol levels. That's why you hear health-related media complaining about them. However, if a food is high in unsaturated fats, where it does have double bonds, it's still bad, but is better than saturated fats. The name trans might sound familiar, or at least it should have, a year ago. This is because the trans configuration on aliphatic unsaturated carboxylic acids is one of the forms of unsaturated fats. This is why you can see trans fats on food labels, and as you can guess, cis is the other. Cis fats normally present little danger. They are the most common natural form and are liquid at room temperature because they cannot pack closely together. Their surface area is less than their trans counterpart, therefore they have weaker van der Waals forces. However, it's the trans fats that are thought to raise the risk of coronary heart disease. They are relatively linear unsaturated fatty acids. They can pack closely together because they have a greater surface area, therefore greater van der Waals forces. Because it now takes more energy to break them apart, they have a higher melting point and are more solid. Food industries also use many unsaturated fats and oils, but they don't always want unsaturated fats. Sometimes you want a more solid food. Although increasing surface area increases van der Waals forces, there is another way. You can have more electrons. So if you add more atoms, you add more electrons, increasing van der Waals forces, meaning more energy in the form of heat is needed to overcome these forces. Therefore, breaking double bonds and adding more atoms makes fats more solid. This is achieved through partial hydrogenation, which is used to make margarine. A future tutorial will be done on this. However, when this is done, the atoms might have enough energy and the double bond might temporarily become weak enough to rotate, meaning the remaining double bonds could turn the fat from cis to trans, making the acids less healthy. But how can these two be unhealthy or healthy? Well, the body uses these things called lipoproteins, particles containing both lipids and proteins, to carry lipids through the body, such as cholesterol and fats. There are two types of lipoproteins, high-density lipoproteins and low-density lipoproteins. High-density lipoproteins are a type of lipoprotein that can remove cholesterol from the arteries and transport it back to the liver for excretion or reutilization. The other is low-density lipoproteins, a type of lipoprotein responsible for carrying cholesterol and triglycerides from the liver to the tissues. Now don't get it twisted, fats aren't fully bad. They can be used as energy, however, if they stop blood flow, it can be quite bad. So, back to the dangers. Trans fatty acids are believed to behave quite like saturated fats. They raise LDL, increasing the risk of heart disease, as they are left to clog the arteries. They also lower HDLs, which are meant to remove the damage. Imagine a section of your arteries as a bath, and the water being cholesterol. The taps are LDLs, and the drain is the HDLs. You are now the trans fat. You want a bath. So you turn the taps up and block the drain to have a nice bath. Except it's a bath of death. So what can we do with them? Well, they're not all bad. They are useful for the production of biodiesel. What's that? Well, due to the harm to the environment, increasing oil prices, and the fact that fossil fuels are non-renewable, we need alternative types of power. One example is biodiesel, which is an ethyl or methyl ester of a fatty acid. It is made by transesterification. Triglycerides react with methanol or ethanol with a sodium hydroxide or potassium hydroxide catalyst to produce biodiesel and glycerol, which can then be sold to pharmaceutical and cosmetic industries. Since the byproduct isn't wasted, the atom economy is improved. Common sources for the triglycerides include wasted cooking oil, palm and soybean oil, and especially rapeseed oil, which the UK has a lot and therefore it has the best potential. But is biodiesel all good? Well, poor countries use their farmland to produce biodiesel to sell to rich companies, instead of using it for food. Biodiesel has also claimed to be carbon neutral, taking as much CO2 in as it uses, but even this has been questioned. And that's it. If you want more delicious science, check out Tutorimations on YouTube. Or, if you just want to see more of me, check out Stream Shenanigans. It'll be swell. Hooray for shameless self-promotion.